Good morning. This is section 4.3, solve a linear equation in one variable. So we have some definitions and properties here, so you might want to hit pause to jot these down. So we have that we solve an equation to find the solution that satisfies the equation. So when we're solving equations, our final answer is going to be whatever that variable is equals something. So it's usually x equals something. So we aren't simplifying expressions anymore, we're solving equations. And equivalent means the same. Equivalent equations are equations that have the same solution set. Okay. Next, the addition property of equality says if A equals B, then A plus C equals B plus C. So this just means that we're going to keep our equation balanced, and we can do that with addition, right? So same thing with subtraction. So if we have two things that we know are equal to each other, if we add the same thing to both sides, they're still going to be equal. With multiplication, same thing. If we have two things that we know are equal to each other and we multiply both sides by the same thing, we know that they're still equal to each other. So solving equations is super important, okay? The most important thing in math is solving equations at every level. So hopefully you saw in the module that there was the list of the equation rules, and then there was a silly little song that went along with it if you wanted to watch that. And then in class, the way that I teach this is I have those cards. So hopefully you saw those cards. They had 6 different things. It was add, subtract, multiply, divide, combine, and distribute. So what I do in class to keep everybody engaged, because I've noticed when I'm teaching this that the most important thing is to stay engaged the entire time, is that I ask the whole class, I say, what would be the next step that I would do? And then you would flip through the cards that I would give you, and then everybody would have to hold up what the next step is that I should do, and I would wait until everybody would get it. Okay, so try to play along. I know it's kind of hard since we aren't in person here, but let's go ahead and give it a try. So first, game rules. They call it the game because if we do that, it makes it sound fun, right? So our game rules are, number 1, we're going to keep the equation balanced. Okay, so whatever we do to one side, we're going to do the other. Second, we're going to undo with the opposite operation. So if we see add, we're going to subtract. If we see subtract, we're going to add. Or if we see multiply, we're going to divide. Or if we see divide, we're going to multiply. And finally, the last rule always, get that variable by itself. Okay, so here is number 1. Are you ready? I have x plus 1 equals 6. Okay, so if you print it off the cards, you can flip through them. If you just kind of are keeping track of them in your head, think about what would I do to get that variable by itself. So let me see here. Maybe I can play around with some highlighters. So I have the x here, right? So here's my, oops, that's not the highlighter. So I have x here, and I want to get it by itself. What is left over? That plus 1, right? We want to get the x by itself. So there's a plus 1. So what is the opposite of plus? That's going to be the operation that I do. So the opposite of plus is subtract. Now, what am I going to subtract by? I have that extra 1. I want to get it off of there, right? So let's subtract it. So a minus 1. But we want to keep the equation balanced. So whatever we do to one side, we have to do to the other. So I'm going to put a little minus 1 underneath of here. Okay, so now on the left, what do I have? I had x plus 1, but I subtracted that 1. So now I just have x equals, I had 6, and I'm taking away 1, x equals 5. Done. What's cool about these, off to the side, I'm going to do it, is that you can go back and you can check your work. Okay, so if we wanted to check it, we'd have that x plus 1 equals 6, and we think x equals 5. So we just plug it in. 5 plus 1, does that equal 6? And yes, 5 plus 1 equals 6, so we did it correctly. If we were to get something like 4 equals 6, we'd want to go back and check our work because that wouldn't be the right answer. Okay? Moving along. Number 2, x minus 2 equals 3. So what am I going to do? So this is where you would find your card. You would hold up a card. because you can see that this x is here. And what's left over? You can see that minus 2, right? So if it's a subtract, then what should we do? We have to do the opposite. All right, so we're going to add. Now, if it's a minus 2, I have to add what to make that x be all by itself? Since it's a minus 2, I want to get that away, so I'm going to do a plus 2. And whatever I do to one side, I have to do to the other to keep it balanced. So now on the left, I just have x. And then here on the right, I have 3 plus 2 is 5. Oh, we got x equals 5 again. Cool, and we can check it. Okay, so if I had x minus 2 equals 3, plug that in. And yes, 5 minus 2 does equal 3, so we did it right. All right, number 3, this one's a little bit trickier. So I have negative 12 equals a negative 3t. Okay, so find that variable here. And we want to get that all by itself. So that negative 3, how's that attached to the t? That's by multiplication, right? So find your card. What should I do to undo this operation of multiplication? The opposite of multiplication, hopefully you got it, is divide. Now, what should I divide by? I should divide by that entire negative 3. Okay, if I only divided by 3, I would have negative t, but I don't want to solve for negative t. I want to solve for t. So I'm going to divide both sides by negative 3. Now, negative 3 over negative 3 is just a 1, so that cancels out. So I have the t all by itself. And negative 12 divided by a negative 3 is a positive 4. And it's okay to leave it like that, 4 equals t. Some students, that just doesn't feel right, so like to rewrite it to have the t equals 4. It's totally up to you. I accept either one, totally fine. And let's go ahead and check it. I'm going to have negative 12 equals negative 3 times, we think t is 4. And if we go and check it, negative 12 equals negative 3 times 4 is negative 12. So we did it right. Number 4, try to find that variable. Try to find your card to see what we would do. So here's that. Oops. Here's our variable. And what's left over is that negative, right? So what am I going to do? Find your card. There's actually 2 answers, okay? Remember that there's really a little 1 in here if that helps you out. My personal preference is to divide. And I like to divide both sides by negative 1. So w equals 5 divided by negative 1 is negative 5. Technically, some people like to multiply. Let me show you what that one looked like. If we had negative 1, w equals 5, they would see that negative 1 and think, well, if I wanted it to be a positive 1, I could multiply both sides by negative 1. When I do that, negative 1 times negative 1 is a positive 1. W equals 5 times negative 1 would be a negative 5. Either way is correct. Just my personal preference is the one on the left, but if the one on the right makes more sense to you, go for it. And let's do a quick little check. So I had negative w equals 5. So negative, I think w is negative 5. And a negative 5 is a positive 5. So checks out. All right, for number 5, I have 4/5 x equals 8. What should I do? What operation? All right, this is another one where you can have 2 answers. First, let me highlight that x. There we go. My personal preference in this one is to multiply. Because if I have 4/5, I can get rid of that by multiplying by the reciprocal, right? 5/4. So I'm going to think of this 8 as 8/1 and then multiply it by that same 5/4. When we do that, you can see the 5's cancel out, the 4's cancel out. So we just have an x equals, I can reduce this first so I don't have such big numbers, right? So the 8/4 I could rewrite as 2/1. So now all I have is 2 times 5 across the top is 10, and 1 on the bottom, which we don't need to write out, so x equals 10. Technically on this one, you could also divide. I'll go ahead and I'll write it out. Yeah, I'll write it out. We'll try it. Not very many people would do it this way, but if it makes sense to you, go for it. So they would write it like this. Divide by 4/5. This would cancel out. Then they would have x equals 8 divided by 4/5. And when we divide, we do keep, change, flip. So x would equal 8. Change the sign. Flip the fraction. So 8/1. And then here's where they would reduce to get to that 10. So again, either way, I prefer the multiplication way. It seems to make more sense to me. But you choose what works for you. And then, of course, we can go back and check it, right? I don't leave myself very much room for this one. So we have 4/5, and I think the answer is 10. I'm going to go ahead and put in 10/1. Does that equal, originally there was an 8. So we have 10/5 can be written as 2/1, and 4 times 2 is 8. Over that 1 equals 8, checks out. Okay, number 6. This one, don't worry about showing me a card for this one. This is kind of a little sneak peek to, in a few days, we're going to solve equations where there's only fractions. So I just kind of want to plant this little seed in your head right now so that when we do get to it, that it makes more sense. And what that piece of information is that when we have these equations that have fractions on both sides, so you see that we have over 3 and over 6, we can do a nice little method here, a nice little skill is to multiply every single thing in our equation by the lowest common denominator. Because if we do that, it's going to wipe out our fractions. Okay, so technically it is multiply. So I'll put multiply. Okay, so the lowest common denominator. So if you don't quite see it, remember this is when we go like 3, 6, 9, 6, 12, 18, and then we can see the lowest thing they have in common is a 6. So we're going to multiply every single thing by 6/1. And what it's going to do is it's going to wipe out our fractions, okay? So the 6/3, I can rewrite that as 2/1. The 6/6 is really just 1. So now on the left, I have 2 times 2x is 4x equals, all I have over here is a 5, right? Because there's 5 times 1 all over 1. All right, now we have to do one more thing. So now on this one, go ahead and figure out what card it would be. So if you're in the class, you would show it to me. So show me your card. What's the next thing I would do? I have 4x equals 5. I'm trying to get that x by itself. It's attached by multiplication, so I have to do the opposite, right? So I'm going to have to divide. And what do I divide by? That 4, because that will make the x be all by itself. So 4/4 is 1, so I have x equals 5/4. Okay. We're almost done here. Number 7. I have 2x minus 8x equals -4. So show me your card. What would you do? It's a card that we have not used yet today. That's a hint. What do you think? I've got the x. Look at that. I have 2 of them. So what should I do first? And this one, the first thing you want to do is combine. Okay, so combine like terms. So 2x minus 8x is a negative 6x equals that negative 4. All right, it's going to take another card here. What do we do next? We have our x here. How do we get it by itself? For this one, that's multiplication, right? So doing the opposite would be divide. And I would divide both sides by that negative 6 because that's what's attached to the x. So I'd have x equals a negative over a negative is a positive, right? So 4 over 6, can I reduce that? I can, because 4 over 6 divide the top and bottom by 2, and I would get x equals 2 over 3. All right, that is our answer for that one. Oh, we can check this one, because this one gets kind of messy, so I'd like to show you how to check it. So after the side, let's rewrite it. Because a lot of times when we have these fractions, they're kind of intimidating for some people, just because we don't have very much exposure to them. So I'll show you that it's not too bad. So I've just rewritten the problem. Everywhere I saw an x, I put in a 2 over 3. And now let's go ahead and multiply here. So we'd have 2 times 2, that would be a 4 over that 3. Minus 8 times 2 is 16 over 3 equals negative 4. And my fractions here have same denominator, so I can combine those. So 4 minus 16 would be a negative 12 over 3. And negative 12 over 3 is negative 4, right? All right, cool. All right, we have a long story problem here. This is the last thing that we're going to do today, okay? So we're almost done. So what we have here is in 2009, there were 186,000 students who earned bachelor's degrees in business, which was 20% of the students who earned bachelor's degrees in any field that year. So how many students earned bachelor's degrees in 2009? Okay, so there's like some big number of all the bachelor's degrees that we don't know what that is. But we know that 20% of whatever that big number was equaled out to be that 186,000. Okay, so let's start with our let statement. So I'm going to put let x be, let's just say like total bachelor's degrees. Because that's what we're trying to find. We're trying to find that total because we know that 186,000 is 20% of whatever that total is, right? So I'm going to write that down in words just because it makes it a little bit easier. So 20% of the total equaled what? That 186,000. I'm just going to put 186. So 20% of total equals 186. 20%, we can write that as a decimal, right? So 0.2, you can put 20 if you want. Of means multiply. The total, we said let x be the total. So instead of total, I'm going to write x. So 20% of the total, so 0.2 times x equals 186. Okay, so now, what am I going to do? So this is where you would show me your card. What operation should I use? So there's my x. It's attached to that 0.2 by multiplication, right? So to do the opposite, I'm going to divide. So I want to get that x all by itself. So I'm going to divide both sides by that 0.20. So x equals, and then just punch this into your calculator. Do 186, then hit the divided by key. 0.2 equals, and you should get 930. And we can label that 930,000. Let's put total degrees. All right, that wraps up section 4.3. I will see you tomorrow. Have a great day.